Hello, PyOhio. I am Alex, and today I'm going to be talking about redlining your CPU for fun and profit in Python. So the core of what we're trying to do today is we're trying to explore really one Python standard library that really makes it quite easy to really get your CPU usage up to 100%. And this sort of gets into like what is the problem of like why we're trying to get that CPU up to 100%. And it's because sometimes when you write a Python script, it might take minutes to maybe an hour or a few hours for it to run. And you can look at Task Manager or System Monitor and you can see it's like it's only using at most 6% of my CPU. There's a lot of, there's many cores here and there. It's like, why not it just use more and solve the thing faster? Really, really big brain kind of ideas. And so this is the core of what we're trying to get at it with just this one simple Python standard library. And to set the just base context of Python by default run as a single thread of execution and a single program. And we're trying to just make it multi-threaded, kind of. There's some technicalities with that one. But for multiple program, that one's also going to be pretty easy to do. And we'll see how this works. So the library we're going to be talking about today is concurrent.futures. And even by its very description, you can understand what this is trying to do, launching tasks in parallel. And at its core, there's really two very useful objects that it contains. The first one is thread pull executor, and the second one is process pull executor. And these two things are going to be what we're going to leverage in order to really get the program to be multi-threaded or multi-program. And to start getting into it, let's look at an example with just process pull executor. And so looking at this code, it's not actually that bad. What we're trying to achieve here is we're trying to calculate if a number is prime. By the way, this code is available in just the documentation for concurrent.future. And so we have a few things here. We have a list of numbers we want to test. We have the function that's going to do the work. And then we have our main body of just executing this. And so normally how you would do this is you would put this in a for loop. You'd loop through all the primes and you're going to ask each of them is prime. But, we have all these cores that we can leverage. So why not try to execute them in parallel? And so looking at the first line of this main function, we can see first we need to create this executor. And so we instantiate the process pull executor within a context manager. And then once you have this executor, you can now just give this executor tasks that it will map out to multiple Python instances. And how that's done is that you call on, whatever name you call it. In this case, I have a called executor. You can say .map, with the first parameter being the function and the second parameter being the work that needs to be done, sort of like any kind of iterable. And what this does is it will spawn up it depends. There's a default parameter, but sometimes you can specify how many workers you would want, but it will essentially split the task across many different workers. And as each of them compute if it's a prime or not, it will then iterate through this for loop. And as you can see, this is like a very, really within probably, if you had to change this from, doing it completely iteratively to this, it was probably only about 2 lines of code that needed to be necessarily changed, which is really surprisingly easy and nice, with essentially being able to spread this task out by just calling .map. So already, like, hopefully you're kind of grasping that, if I just want to just spread out a task that is like computationally intensive to multiple Python programs and then have those execute over multiple cores, this is the easiest way of actually achieving that. And so let's look at an example of thread pull executor. And so in this example, we have kind of the same style, instead of primes, we have a bunch of URLs that we want to call requests on. We have this function called load URL that will then get that page, get its contents. And so this is kind of the same setup, except now we're going to be using the thread pull executor. And actually notice this time in thread pull executor, I give a maximum amount of workers. And so this one, pretty much the setup is the same. It's just now we're doing a slightly different way of actually submitting getting the executor to perform tasks. In this case, I kind of gave it away. It's submit. So submit takes in as the first parameter of the function and then just the arguments that function take. And so in this case, we're providing load URL, we're providing its URL, and we're providing a default timeout of 60 seconds. And the key thing of why you may want to do submit is because submit would return a list of futures. And then with those futures, you can ask if they're complete or not. There's some additional things with futures you can probably do. I would say probably in this case, map would also be still fairly acceptable, but there might be other good reasons of why you're doing it like this. So for maybe a brief example of why this is because essentially, if you notice on the for loop, you can say futures.asCompleted. You can literally fetch them as completed. So maybe the second one actually finishes downloading website faster than the first thread. And so this is kind of trying to actually really optimize and actually get things to run really quickly so that it can keep calling up new web pages. And the key thing with these feature objects is whenever you want the results from them, you have to call feature.result. And this will either block and just wait until the function has finished executing, or it will just return the data back if it's completed. And there's additional properties like you can check if it's running, if it's completed, etc., etc. And so I think now that we've seen two examples, there's some things that we want to see that kind of like when to know you can sort of do this, or not even when to know, but like kind of see like the pattern forming. And there's a few things. Like one, you can basically encapsulate all the, like you can make it so that you can do this function that you do work as like a single point of entry to be called. And so like this is the is prime, this is load URL. You know, just a single point of entry kind of like function that will then execute and start doing work. The other key thing is work is represented in a list and can be chunked up. And why I say it can be chunked up is because I'm thinking about like the task being split across either multiple threads or multiple processes. And that's kind of another thing that's to notice. If you're looping, this is probably giving a hint that, okay, if my day is in a list, this is probably the time to do it. And the last one is your work is CPU or IO bound, which is pretty much, it's either one or the other for most of the work that's ever being done. And so now sort of, I want to give you just basic heuristics now that we have like, okay, if I'm seeing these basic things, then probably I can just use these libraries and I can quickly now speed up the execution, get things done a little bit faster. And so probably sort of the just default way to think about things, if you have something that's IO bound, like, you know, calling requests, doing file IO, thread pool executor is going to be your main one you want to use because that actually will speed up those kinds of tasks. But for more like computationally intensive, you want to use process pool executor. And there's a lot of reasons for that. Sometimes threading in Python does not exactly work the way you would think it would for when the application goes multi-threaded. And so it actually just makes more sense to just create multiple Python processes and have them execute than actually trying to make one execute and do with multiple threads. And so this is like sort of like kind of like the basic general rule I would give. Now, technically, what if your work is a little bit of column A, column B? And, you know, there's nothing really stopping you now from like, you know, doing like a hybrid approach where it's like I have, you know, this has to do some file IO, but this also has to do a lot of computational work. And so there's like a way where you can spawn multiple processes, and each of these processes are doing multiple threads. So maybe you have like, you know, 4 Python programs that each have 4 threads that are doing requests on all these pages. And so you're really distributing the work across. And my experience is once you're starting to do kind of stuff like this, you really are like starting to slow down your entire computer to a grinding halt because all it's doing is these Python tasks and you're getting it done a lot faster. And so hopefully this kind of exploration into this one library and showing you how fairly simple it is kind of to really add to your existing code to really get your CPU usage up to 100%. I know like every time it's taking forever for me to do something, I just sometimes just slap this in and then get my CPU up to 100%, and within like no time I'm at my results. So hopefully gain something today. Thank you for watching. I hope you enjoyed my talk.